This is the Valentine supercell chase. Valentine, Nebraska is right about in here. Here's your 500 millibar trough at 7 p.m. July 13th. You can see the winds out here, again, aren't real strong, just like the Dupree chase was only about 25 knots. You got 25 knots at 500 millibar, 18,000 feet at North Platte, 45 knots at Rapid City, and the storm fires off the Black Hills, basically, and it turns down this way and goes south. Eventually, it gets into these weaker winds. I want to note one thing, and the trough's kind of far back here yet. But if you have a ridge, this is a trough, your storm, a ridge between it and the next one, rising heights, really sinking air, warming temperatures. So on chases, you generally want your heights not to be rising. These are the height lines, pressure. So if those are lifting and getting higher, it's gonna be harder and harder to get storms. You want your heights to not be rising. This one's kind of weird because you got this bulge up here, but these aren't really rising very much. So when the system comes in, these will be lowering heights. Anyway, it's something to think about. Temperatures are off -8. Since summer, July, middle of July, so your mid-levels are getting warmer than they were in the spring. But this ain't bad at all. You'll see on the soundings, Rapid City sounding and North Platte sounding in a second. Here's a 700 millibar, roughly 10,000 feet above sea level map the morning of, so 7 a.m. Central Time. Here's your trough. The red lines are your temperatures at that height. So again, you got 11 Celsius in North Platte, 12 in Rapid City, and you can see the lines. So your capping is kind of the hotter air down here, kind of advecting east, because these will warm a little. See the southwest winds at this height moves east, and at first they want to warm, but they don't warm too much to keep a storm from forming. And what sometimes will happen is a storm will kind of be at what's a cap rider, called a cap rider in a way, where it'll just ride on the edge of the cap. Something will get it to fire, and the cap's strong enough to keep other things from firing, so it kind of stays isolated and just has its own environment it can go through as a low-level flow blows into it. And it kind of rides the cap. The cap's trying to warm, but at the same time, it's going to start cooling as these heights lower. Cooling aloft comes in. But first, because this is morning, so it bulges and then it gets cool on this setup. You also see the moisture. Usually, you got that much moisture showing up at that height. There's probably clouds. Better have drier air in your mid and upper levels. Anyway, I guess I should go to the evening. There's the change to the 7 p.m. Go back to morning, 7 p.m. You can watch the height lines kind of go down as that trough up here moves east during the day. But watch the temperature lines. They kind of get warmer, they kind of budge in, but they don't get too warm that the surface temperatures can't overcome them on this setup. You're talking 14 now at Rapid City and North Platte. And the storm fires off the Black Hills. Talk about that in a second. And it goes east and then turns south. You can almost see how it would, riding a cap, but also the shear kind of dictated it would go that way. I'll show the rest of that. Here's the evening upper air map at 300 millibar. See your upper troughs up here. It's roughly 30,000 feet above sea level, getting close to your anvil level. You can see 75 knots coming out here, but 45 knots down there. But you'll see it. Sometimes it pays to look higher up on the soundings or the maps, where this is only 30,000 feet. That storm ends up being like 45,000 feet. It's probably the anvil level. This top probably went over 50 a few times. And it fires here early-ish, mid-afternoon or so, and then by 7 p.m. it's probably crossing the Nebraska or South Dakota border around here, right near Valentine. It tracks right over Valentine, Nebraska. Anyway, you can see the flow aloft's pretty decent, especially for a southward moving storm. That's the thing. If the storm's going to fly east at 30 miles an hour, then this storm relative flow up here becomes less. You think about that. The wind's blowing 75 and the storm's moving, say, 35. Then up at that height, the storm relative flow is going to be like 40. But since it's going south, it's getting all that, plus it's moving south as well. So it's kind of adds to it. So it really had great vent aloft and anvil level flow. And I'll show you on the soundings. Remember, Rapid City's got 75 knots at 300. And North Platte's got 45 knots. But I'll go above that on the sounding and show you the even higher up winds are probably a little better where the storm is. Because you'd guess, at least at this height, they're probably, I don't know, 55 knots in here as a guess between these two. Now, if you look at North Platte sounding, which is south of where the storm fire moves, you can see if you look at 300 millibar, roughly 30,000 feet, you're almost only halfway. You're a little bit over halfway up the updrafts, because the updrafts, all this cape and instability, updraft anvil level is going to be up in here. The updraft might be going up even higher. So 300 millibar works better in spring, you know, because it's storms are a little shorter then. But towards summer, when the storms are getting taller, better probably to look higher up even, or just look at a sounding, because at 300 millibar, you're only seeing 40, 45 knots. But up above there, you even down at North Platte, you had 65 knots higher up. That could be worth looking at. And if you switch over to Rapid City sounding, but they had plenty at 300 millibar to begin with. They had 70 knots, 75 knots. You can see it's about the same aloft above there. But now, if I go back to North Platte's, look at the low level. It's sort of an inverted V. It's not horrible. But the thing to look at is this warming. It's not warming, but it's not cooling. Because remember, your temperature lines on this graph are going this way. So everything this way, everything on this line is 10 degrees Celsius, 20 degrees. So if your air temperature cooling, but then it goes this way, this whole distance, that temperature is staying the same. So it's kind of capping in here. You don't want it to stay the same or warm up. If you're warming, you're capping. Staying the same, you're pretty much capping too. So if you think about that, North Platte's kind of capped. It's a little not great. And if I go to Rapid City, you see Rapid City, it already moved by there though. It formed earlier near Rapid City and then moved east. You can tell by 7 o'clock, Rapid City's got a cap, warms up, and then it falls off again. You see it's got a lot of convective inhibition, 122. Cap strength 4 degrees Celsius. Or if you look at North Platte, they don't have any convective inhibition on there, but they got 1 degree Celsius cap strength. So anyway, if you think about that was on that map where the 700 millibars were warming up in there, this storm's kind of on the outside of where that bubble is. It's kind of riding on that cap. You can see, because if North Platte's kind of capped and Rapid City's capped, and North Platte's barely capped, Rapid City's sort of barely capped. It fired there earlier. So that warmer air is kind of moving in behind it too. Also, should probably mention the shear. You can see North Platte is south of there at 7 o'clock. Nice turning in the low levels. From the ground, you're at 15 knots from the southeast. And already by 10,000 feet, you're from the west. But it's not strong. It's only 20 knots. All the way up here, it's still only 20 knots. Start getting better at 300 millibar, but you're starting to get up there. And the low-level jet was really only 20 knots, but that'll really increase after 7. So you can only think about that so much and just realize it will be stronger after the sun gets lower usually. And your ground's still warm. I mean, it takes a while for your temperatures to start cooling off, so you get all that nice warm air, but then the flow starts to pick up after the sun goes down or the sun gets lower. And you'll notice in front of the storm especially, the winds were really, really strong. With inflow gusts probably pushing 70 miles an hour at times. Just because it's all that strong air rising. You got a strong updraft and you got a bunch of wind taking the top off the storm. So you end up adding to that inflow. Here's basically the low-level jet height, the 850 millibar, 6,000 feet or so above sea level, where you want all your low-level moisture, top of it to be around, you want your low-level moisture. And up here, there was a big upper low. So behind the upper low, you had a cold front come down, dry everything out, push all the moisture back south. So you can see all these green lines where the deeper, higher dew point air is, where it's drier. So that front come down. So you get that warm front deal kind of going back up ahead of the next one. A lot of chases. You can see the dew points are at 850 millibar are really good. 17 Celsius dew point at North Platte. This whole area is really good low level of moisture. The flow again isn't real strong though. It's only 25 knots at 7 p.m. I don't know what it increased to. I know the Storm Prediction Center's got some composite indices, and the significant tornado indice was I think a 9 or maybe an 11, which is just insane. It's hard to usually got big cape and big shear that goes into that. Usually when you have big cape, you often have a cap. You don't get any storms. So a lot of times you'll see that value real high, but you don't have a storm in it. When you have a supercell in it, it's pretty rare. It doesn't happen very often. And this supercell moved into that sort of environment because it had the big cape, and the shear was getting really strong towards the later evening periods. You'll see how crazy the storm goes because of that. Now, there'll be quite a bit to see on this satellite loop. First off, this dark area, that's the Black Hills. Higher elevation with those hills. It's just like the front range of the Rockies. You get upslope flow, and those hills act like a front where they'll force the air up and cause a storm that way, called upslope. You got low-level moisture, southeast or east winds going up this. Oftentimes, that's where your storm will fire right off the front range or these hills, and that's what happens here pretty much. This storm fires right there, cracks as a supercell forever, goes south by Valentine. I'll go forward here. And there was a nice storm trying to get going up here, and I got suckered for at least a little while, but it was pretty garbagey by the time it got to me, and it was getting elevated and elevated. And finally I broke off and went west and came back south to the interstate where I intercepted the supercell near Kadoka, I think it was. See, now the Valentine storm's getting ready to fire right off the front of the Black Hills. And you can see that storm looks pretty decent on satellite. Got a nice V to the updraft, the anvil. Nice shear up there. Low levels weren't that great though. See the low level cumulus moisture all in here feeding back this way. Now you got yourself a supercell. Boom. Boom. Getting even bigger. And there was another supercell went up just north of it. But this one wouldn't do well because this one was creating, rain cooled air, and the whole inflow was going to direct that rain cooled air to this one. So eventually this storm would hit that air and it would die. It would have a while because the air is good for a while until it either moves into this junk air or else that air gets blown into it. So it lasted for at least a while. But watching this thing, I don't even know if I remember noticing that. Thing, you can almost see the edge of the moisture, and it just follows that. See the cumulus clouds down here, your cap, hot air aloft, probably building in here because Rapid City was sort of capped, and North Platte was just kind of on the verge where the temperature wasn't cooling in that certain area down low. So you kind of consider the cap right there, and the storm's kind of right on it. Now it's even turned right. Sometimes they'll turn into the best moisture if they can. Hard to explain that, how that happens, but then your winds were weaker. Sometimes it has to do with your steering winds are weaker, so it kind of lets itself propagate just where the updrafts are firing. It kind of just keeps refiring and kind of guides itself that direction. Now it's already dark, and it was going the craziest right now. You can see all the intense updraft tops just bubbling up everywhere. I'll let it play this time. See just how big that anvil shield is. That's huge. Now I'll do the radar. Storm fired up the Black Hills way out there. Got better and better, and it was producing crazy frequent lightning right in there. See, it's kind of struggling at first. Moving pretty quick at first too, and it slows down and just turns due south. Trying to slow this down. See, yeah, it's kind of, well, the radar might be screwing up, but yeah, it's not very clean looking. It's just kind of, it's round supercell shape, but it's kind of goofy looking. But the first shot I take, the first shot on this video will be right about here. It's really high based. You'll see how high based it is. A lot of times they'll start that way and you try and lower. If they can stay a supercell and keep its cold pool, its cold generation, because when it's high base, it's probably in drier air. So it's when it's raining on it, raining around it, it's making a lot of evaporative cooling. So if it can keep the storm in check size-wise until it gets to better moisture, it has a chance. This one didn't really do that. It just had a lot of problems with being outflow dominant, but it was still a beastie supercell. It could still be that. It just has a harder time producing tornadoes through that route. And it got tricky to stay with too. You had to go south as it went east of you and then cut east. But for this area of South Dakota, it was actually going pretty good for road options. And it starts getting a little better. It started hitting some better moisture in there. And then the next set of photos where I show it far and close will be right now. I'll be like right about here. The first shot shows a little further away, and then the next shot shows it closer to here. And then it really turns south, and it right over Valentine. It gets another storm kind of pops up right in front of it, and then that takes over. You'll see that's when it goes the most crazy looking. Bam! That goes up in front of it, but it takes over anyway. It just starts spinning right away. Watch. Bam! You have a crazy hook, and you're getting higher indicated hail or higher reflectivity, indicating probably bigger hail, more hail. A nice hook. And there's a road south and a road southeast, and it had been going this way. You had to decide to go southeast, and if it goes south, it's really hard to get back to the sandhills off the main highways. So I was really stuck deciding at this point, and I decided south. Then the thing turned and goes straight south, just west of the highway and just on it. It's so crazy. I couldn't believe what happens. Watch. See how it starts turning, and then this starts another area back here. Comes around, and it's just a beast when it was in here doing this. Just incredible. I'm surprised it looks like it moves through there so fast on radar, because it actually sat there at the time for quite a while. And then it got turned into a mess. And finally, here's the surface map. This is at about 2 o'clock. You can see, if you look, Valentine south, and then these are east or southeast, east-southeast. So there's a warm front in here. Look, Norfolk's kind of east. So where that big upper low was, that front's trying to lift back north. And here's another setup where your pressure isn't very low at all. It's kind of just like a northwest flow or west flow aloft setup. Sometimes you don't have much of a surface low. You can see 099, so that's, you got to put a 10 in front of there. So that's 1009.9 millibar, 1008.6 millibar. Generally, it's not good if you're not in the 990s at least. But as this shows, it still can work. And if you look at the dew point spreads, 86 over 65, that's 21. It's kind of high on this day. It gets worse, as the day goes on. It'll get bigger, but it wasn't bad for out west. I mean, heck, look at North Platte at this is 2 o'clock. Almost a 70-degree dew point clear out to North Platte. Hard to get real high dew points out here. So that's really really good for North Platte. And even up here, Pierce 65, 63 at Rapid City. Now watch when I switch this to 8 p.m. Watch North Platte or Valentine. Got the thunderstorm symbol. 83 over 67. That storm's moving into town. And Ainsworth is 79 over 68. So that's really good air for this far west any time of year. But notice the winds at Valentine. Got 35 knots. I guess that could be. That's not part of the 7. That's another barb, I think. Anyway, say it's 35 knots. You're talking a little over 40 miles an hour, 40 mile an hour winds. That's just sustained winds. So that storm is clearly affecting the winds around Valentine. The inflow near the storm just ramped clear up because everywhere else, look at everywhere else, 15 knots, 10 knots, 5 knots, 10 knots, 10 knots, 35 knots or 30 knots, whichever it is. Rapid City's gone northwest now. Anyway, there's the surface. Rather good air for this time of year, but the storm probably had its problems already before that point with outflow. Because look, at 2 o'clock out here is 90 over 59. That's 2 o'clock. 88 over 63 in Rapid City. The storm fired, I don't remember what time exactly, but it wasn't too much later than that. So there's pretty decent spreads out here. So the storm fires and higher spreads, it might give itself problems with evaporative cooling and cold outflow becoming more dominant mode of the storm. Especially with its near hot cap too. Tends to happen.